All right, a quick rundown of that lab, and then I'll talk about the problems after it. So what you did, and this is stuff we already did together. So you found the line of best fit, going like that, right? And I would strongly urge you to, so you get that line of best fit, and I would go until the line ends. And I would always, with lines of best fit, use those endpoints of the line. So whatever the values were here and here, use those endpoints. Don't use the points you were given. Use the line that you picked to do your calculations. And first thing was you needed to figure out the acceleration, which you did here, but you had 1.6 minus 1.26. And I think we figured out that we really wanted to have the whole line. I could be wrong with what your teacher prefers, but I would, you could use the whole line. And it would be, again, the reminder that acceleration of a velocity versus time graph is a slope, right? So it's y2 minus y1 over x2 minus x1. If your teacher says they want to use the endpoints, you could go, the point from here to there and then do it, but then you really don't need the line of best fit anyways. Okay, so that got your slope. And then it was talking about the displacement. And we talked about that, how the displacement, if we want to get the displacement of it, we would really have to first just get a flat line here, okay? And then we would have a vertical line coming down like that. Okay, and then what we would do is we would just figure out the area. So we'd have two areas. We'd have the area, area 1 would be a triangle. Oops, I just did area 2. So area 1 would be a rectangle because I don't want to erase. Area 1 will be a rectangle. Area 2 would be a triangle. So to get your displacement, you'd have to add the two areas. So area 1 would be base times height. And area 2 would be 1/2 base times height. And, so your base here would be, I do remember that was like 0.2 over here. So you'd have 0.2 as your base. And your height would be whatever the height of this value is here going over there. And I forget, I think it was a number less than 1, but whatever you estimated that value to be there, okay? And then the triangle, this height of this triangle right here, well, I guess I'll do base first. So we'd have 1/2. Your base again would be 0.2. And your height is going to be really the height you got from the slope up here. So you would just subtract these two values. Whatever you got the line to be, the change in y from here to there, that's what you would put in for this point for the height of the triangle. So just understand that this height is different than that height, okay? And the height 1 was just from here to there. I'll give you a different color. The height 1 was from here to there. Height 2 is from here to there and uses this calculation. Okay. All right, now let's look at the other questions. And then you got to do percentage difference for gravity, and that was just going to be whatever your slope was that you got here, minus 9.8. So, whatever you got it to be. And I think let's say you had 11.33, and I know we were talking about those weren't with the line of best fit. So if you did that minus 9.8, you would get a value a little less than 3 or something. And then you would divide that value. So I'll do it real quick. 11.33 minus 9.8. I got 1.53. If I divide that by 9.8, I get that it was 15.6% off. So my percentage error would be 15.6%. All right, and I know you were going to think about doing a different numbers if we're using the lines or not. Okay. Now, a body falls freely from rest on Earth. Its displacement, find its displacement at t equals 5 seconds. So, for that problem, you're just going to do, 5 seconds. Yep. So I have t is equal to 5. We want to know its displacement. I write as x, f, or d. It depends on what you're given in the equation. And you have acceleration is 9.8. I write it as negative 9.8, but You know, I'd say that's a safer bet unless they really care about it and say positive or something. So the formula you're looking for is something that has the 1/2 AT squared at the end. Okay, usually you have a VI times T plus 1/2 AT squared. Sometimes you even have an initial position, but we'll put it like that. So we're going to say, all right, the formula is going to be XF is equal to VIT plus 1/2 AT squared. The object was dropped. I still see the word drop over here. Okay, so, and it's freely from rest, either one. So I see the initial velocity is going to be 0. Anything times 0 is 0, so that's gone. So all you have is a 1/2 AT squared. So you have 1/2 negative 9.8 times 5 squared. I plug it in, 0.5 times 9.8 times 5 squared, and I would get negative 122.5 meters as your final position or displacement, however you want to write it. And I'm guessing your teacher wants displacement because that's what they asked for. Okay, so that was the first one. How long does it take for it to reach a speed of 25 meters per second? So if we take this down here, we say t is equal to question mark. VI is still 0. Acceleration is still gravity. And speed of 25 meters per second. That's really VF is 25. It's going to be negative because it's going down. Okay. If your teacher doesn't care about negatives, you could just ignore the negatives. I like to always make it as negative 9.8. Okay, so with those, I would pick the equation VF equals VI plus AT. I would do my algebra where I solve for T, so subtract VI on both sides. VF minus VI equals AT. Divide both sides by A. Yoink, yoink. So I have VF minus VI divided by A is equal to my T. So I have VF negative 25 minus 0 divided by negative 9.8. I divide that out, and what I get? So basically those negatives will cancel out now. So we have 25 divided by 9.8, and we get 2.55. Okay, the time required for it to reach 300 meters. So again, you're looking for T. Woo! Where'd it go? There we are. So again, we got T. My hand's going crazy with it. T is, eraser. T is equal to question mark. The distance, XF slash D, is equal to 300 meters. Initial velocity, it's still dropped, so it's still 0. Acceleration is still gravity, still negative 9.8. We'd go back to that other formula we used up top. Okay, the XF is, or distance, whatever you have, VIT plus 1/2 AT squared. Again, the initial velocity is 0, so again that gets crossed out, and you have XF is equal to 1/2 AT squared. Okay, but this time we're solving for T, so we wanted to multiply both sides by 2, so the 1/2 gets canceled out, and we get 2XF. So far we have 2XF is equal to AT squared. Now I'm going to divide both sides by A. So I have now T2XF divided by A is equal to T squared. And finally, I got to square root it. So I square root both sides. And I have T is equal to square root 2XF divided by A. And you plug it in. 2 times 300 divided by 9.8. Now this is negative 9.8 down below, but the 300, it fell down 300, so that's negative as well, so the negatives cancel out. So you just plug that in, second square root 2 times 300 divided by 9.8, and I get 7.83 or 2, something like that. Whatever. Okay? All right, so there's the first one. I'll record another video for the other one.